All right, ladies and gentlemen, so we're going to get started with another kind of substitution. Now, this is generally when U substitution fails. And if you sneak a peek at these, you start noticing some problems when picking your U. The derivative of U will not equal something like X. This will equal something like just 2. So that's where the issue comes in. So here's the trick. What you're going to do is you're still going to pick U like normal. U will be the stuff inside of your function. So it's going to be U equals 2x minus 1. And you're going to run the process like normal. So we're going to get its derivative, so du over dx equals 2. So when you solve this using the u sub method, you get 1/2 du equals dx. And notice how the dx doesn't have that x it needs to match to be able to fully substitute. So here's what you're going to do. Here's the new step. I'll do it in red. You're going to replace this x with something and the 2x minus 1 with something. So you're going to solve for x using the u. So when you do that, you add 1 to both sides and you divide by 2. So, whoops. So that what equals x. Okay. So now it's like a double u sub. What you're going to do is your x gets replaced by this and your 2x minus 1 gets replaced by u, which means when you substitute, okay, so now you're going to sub, it's going to be 1/2 integral du, because you still use the 1/2 in the du. X was replaced with u plus 1 over 2, and then square root of 2x minus 1 becomes u to the 1/2 power. Now notice, I know it's supposed to be square root of u, but I just put the 1/2 power just to save time. So now we can simplify this a little bit more. See how this is being divided by 2, and then it's times u to this? Well, that's the same thing as times 1/2. So I'm going to bring that 1/2 out to pair with this 1/2. So this becomes 1/2 times 1/2 integral of u plus 1 times u to the 1/2 power du. And we can see that this 1/2 and 1/2 ultimately become 1/4. Alright, so what we want to do from here is some quick distributive property. Okay, so this is going to be 1 over 4 integral. And remember, the secret power on this is a 1. So what you're going to do after you do distributive property is this becomes, you add the exponent, so it becomes u to the 3 over 2 plus u to the 1/2 du, okay, because of the distributive property. Now we can start integrating. So when you integrate, you end up with 1/4, and then now we're going to, it's 1/4 times the integral of all this, so it's going to be u to the 5 over 2 over 5 over 2, because you add 1 to the power, plus u to the 3 over 2 over 3 over 2 plus c. And you're done. Okay. So there's 5.8. Alrighty. So now we're going to do another kind of u sub with the 1 and the 5. Again, the process is relatively the same. Nothing really changes except for that new substitute x part. Now I don't like having parts of my function in the denominator, so I'm going to fix this. This becomes the integral from 1 to 5 of x and then 2x minus 1 to the negative 1/2 power dx. So let's run u sub like normal. 2x minus 1 will be your u, so u equals 2x minus 1. Du over dx will be 2, so that means 1/2 du equals dx. Can't really simplify, so we're going to solve for x. Sorry, can't really substitute, so we're going to solve for x to replace this x right here. Excuse me. So this becomes x equals u plus 1 over 2 again, so that's very convenient. It won't always be like this, but a highlight here. This will replace this, and this will replace that. That way you can see visually what's happening. Alright, so now let's substitute. So now it's the integral. Remember, the limits are going to change. 1/2 and du go to the back, and I'm actually going to need a little bit more room. Alright, 1/2 and du. And then from here, x became u plus 1 over 2. So u plus 1 over 2 times, and then it's u to the negative 1/2 power. Okay, so there's all our pieces. The over 2 part can be pulled out to go to the front because it's just a constant. So this is 1/4 integral of u plus 1, I'm going to put that in parentheses, times u to the negative 1/2 du. Now, like before, we're going to do some quick distributive property. So this becomes 1/4 integral. Now remember, the exponent on u is 1. So 1 plus negative 1/2 is just a positive 1/2 plus u to the negative 1/2 du. Now we can integrate. Oh, wait, before we integrate, I'm sorry. Before we can integrate, what we need to do is write our new limits. We never did that. So our new limits are just like before. I'll do those in green. You will take your old limits and throw them into u. So one of our new u's is 2 times 5 minus 1, which is 9. And the new limit down here is 2 times 1 minus 1, which is 1. So 1 and 9. 1 and 9, 1 and 9. You don't have to write on all of them, but it looks nicer on a free response question. All right, so now we can start doing our integral. So where was I? This is 1/4. Okay, then it's u to the 3 over 2 over 3 over 2 plus u to the 1/2 over 1/2. No plus c, sorry, no bracket either. Then the bracket goes over all this, 1 to 9. Okay, now of course this does require a lot of rewriting. So the way this is going to be rewritten is, this is going to be, let's see, the 2/3 is going to flip to become 2 over 6, actually 2 over 12. Okay, square root of u, and I'm going to cube all that, plus, see, because it's top in, bottom out, and then plus, and remember the 1/4 is being distributed to both of them, so this is now going to be plus 2 over 4, and here I'll show you what I mean by that. The 1/4 is applying to both. That's where I'm getting the 2 over 12 because of these two, and 2 over 4 because of 1/2 and the 4, with the 1/2 being flipped. Okay, and this is the square root of u. Okay, and we're still plugging in 9 and 1. So this is where your brackets come in handy. First we're going to plug in the 9, and then we're going to plug in the 1. So this is 2 over 12. The square root of 9 is 3 and then cubed, plus 2 over 4 and then times 3. I'm going to leave it like that, just to not have to simplify too much of it. Okay, then from here, we're going to plug in the 1 now. So we plugged in the 9, that's what generated this. We're going to plug in the 1, this was going to generate this. So now it's going to be 2 over 12 times 1 plus 2 over 4 times 1. And you sure this is 1 cubed, 1 square root of 1, then cubed, and that's still 1. I'm going to leave it like this. Okay. Solve later, just to save time. If you have a calculator, sweet, plug it in. All right, so next one right here, same idea. I'm going to rewrite it first. So this is going to be the integral from 0 to 7. Let me make this in black. So the integral from 0 to 7 of x plus 1 to the negative 1/3 power. U is x plus 1. So du over dx equals 1. Du equals dx. That's convenient. Okay, that's going to be very nice later. Let's solve for x while we're here. Okay, so it's going to be x equals u minus 1. That's also very convenient for later. All right, so now let's sub. This is going to be the integral of u minus 1, because that's what the x was replaced with, and I'll highlight that while I'm here. Red simplifies red, or substitutes red, and blue will simplify blue. And so we can see it here. Here's your red, and what I'm about to write will be in blue. So this is going to be u to the negative 1/3 du. New limits. So this is u equals 7 plus 1, which is 8, and u equals 0 plus 1, which is 1. So from 1 to 8. Notice the new limits are important. Alright, so then from here what you want to do is now some quick distributive property. So this is going to be, you're going to go from 1 to 8 of u to the 2/3 minus u to the negative 1/3 du. Quick integration. So this is going to be u to the, let's see, add 3 over 3. So it's going to be 5 over 3 over 5/3 minus u to the 2/3 over 2/3. And this goes in from 1 to 8. I'm going to rewrite this as u cubed rooted and then to the 5th power. And then actually I'm going to rewrite this even better. Instead of over 5 over 3, this is 3 over 5 minus, sorry about that, a little glitch, minus, and that's going to be 3 over 2, and this is going to be the cube root of u, again, squared. And this is still with 1 and 8 being plugged in. So again, I'll let you guys plug that in. I'll plug them in just to get them started. So it's going to be 3, and then the cube root of 8 to the 5th power over 5 minus 3 cube root of 8 squared over 2 minus, and then now we're going to plug in 1, so it's going to be essentially 3/5 minus 3/2, and then solve later. Okay, so here I'm going to see if I have a calculator. Great. I think the cube root of 8 is 2, so these numbers aren't so bad to calculate. They'll be a pain in the butt if it's a multiple choice without a calculator, but you should be able to handle it. So if you flip onto the next page, here we have some shortcuts. Okay, so some shortcuts. And they're really nice shortcuts. So essentially what you can do is, if you have a function that is even, then f has y-axis symmetry, which means it reflects across the y-axis. All right, and then it gives us a nice little rule. If you have the integral from negative a to a, so let's call this from negative a to a, and you have the integral. And the most famous even function ever is the parabola. Okay, now if you have an integral from negative a to a, that would be these areas right here. It would be this area plus this area. Of course, I would have drawn it a lot nicer, and they would have been, you know what, actually what I can do is keep moving that to where they kind of look the same. Okay, and let me move this over here. There you go. So from negative a to a, what happens here is that if you just get the integral from 0 to a and you double it, you have the same thing. Because notice, if I had drawn nicely, this area and this area are equal to each other. So what we did was just add them together, and it's the same thing from 0 to a. So that's a quick little property there. That'll be nice. Now if you have if f is an odd function, then f has origin symmetry, which means if you were to rotate it 360 degrees, it'd be the same no matter what, or 180 degrees, it'd be the same. So here's what it's going to look like. Okay, the most famous odd function from negative a to a will be what's known as your x cubed function. Okay, so this is your x squared and this is your x cubed. So you can see even, odd. And now if we generate those areas again, you can take a guess at what the area is going to be if you combine these two. This is a negative area and its positive counterpart. So the area from negative a to a of an odd function, or the integral, will be 0 because they cancel each other out. So here we have some properties and some rules that we can see, or put into practice what we just learned. They're telling us that f is an even function and it goes from 0 to 5. We know that the integral of 0 to 5 is 3. So they're asking us to find the integral from -5 to 5? Well, because it's even, we know that if you go from the left all the way to the right, it's going to be like 3 times 2. Because as we just learned up here, negative a to a is the same thing as doubling from 0 to a. So we double 0 to 5. This is 2 times 3, which is 6. Now we know that the area from -5 to 0 will match from 0 to 5 because it's even. There's symmetry. They're the same. So this will also just be 3. And then from here, if we know from -5 to 5, but they have this 4 out here, in here, we can take it out. And this is just 4 times what we already know this whole thing without 4 to be. Without the 4, that's just 3. So it's 4 times 3, which is 12. Oh, wait a minute, not times 3. This is where I made a common mistake by not paying attention. The answer from -5 to 5 is not 3. It's 6. We figured that out earlier. My bad. So it's 6, making this 24. Now we see the odd counterpart question. We know that from 0 to 5 it's 3, and the function is odd, so it's looking like this. From -5 to 5, so if we go from here all the way to here, we notice that they're going to cancel each other out. So you end up with a big fat 0. We know that from -5 to 0, that's the negative counterpart over here. So if we know that this one's positive, its opposite will be negative, which is -3. And again, with the letter C, you take out the 4, and it's 4 times a big fat 0, because we already got that answer earlier, giving us a 0. Now this next part, this gibberish of all these letters and pluses and little dots and stuff going on, we're going to be skipping it. Okay, so we'll learn that later when it's important to learn it, right at the end. Okay, so please make sure you skip this part and the next page also. Hold on to it because we will go over it later, or there will be a video on it later. So we're technically done for this section. Okay, and just a heads up, don't forget to change the number to 5.8. I remembered this time. Alright guys, so thank you so much for watching this video, and we'll see you all on the next school day. Have yourselves a wonderful evening. Goodbye.